All right, so today we're going to look at two methods for simplifying square roots. They both have their pros and cons, depending on how well you know your multiplication tables. So let's look at simplifying the square root of 48. So the first method uses the product rule of square roots or radicals. So let's look into that into more detail. So we have the square root of 48. And I want to write it as the product of a perfect square and another factor of 48. So I know that this is equal to the square root of 16, which is a perfect square, times 3. Now, we can then split the square root into two parts. So this is now the square root of 16 times the square root of 3. And we know that the square root of 16 is a perfect square. So this is 4 times the square root of 3, which can then be written as 4 square root of 3. So that method is really nice and very fast if you're able to see what perfect square goes into 48. Now, if you can't see which perfect squares go into 48, I would recommend making a factor tree. So start with 48 and split it down into any two factors of 48 you know. So a common one would be 6 and 8, because 6 times 8 is 48. Then from here, we can keep breaking down 6 into another factor, 2 and 3, and 8 breaks down into 4 and 2, and this keeps going to 2 and 2. Now, once you break down your factors all the way, I like to circle them. So now we can write 48 as a product of its prime factors. So this would equal the square root of 2 times 3 times 2 times 2 times 2. So 2 times 3 times 2 times 2 times 2 equals 48. So now what we want to do is we want to make perfect squares by multiplying the same two numbers together. So when I look inside my square root right here, let's make a perfect square. So we know that 2 times 2 makes a perfect square of 4, and the square root of 4 is going to be 2. I can make another perfect square with this 2. 2 times 2 also makes 4, and the square root of 4 is also 2 times 2. So right now we have 2 times 2 times the square root of the only number left, which is 3. And then you multiply these and get 4 square root of 3. So the factor tree might take some more time, but it is a very efficient way to simplify square roots if you cannot see what perfect squares go into it. And we are done.